Okay. Okay, so I didn't realise I wasn't streaming, so I'm going to just do this again from scratch. Oh, God. I'm so sorry about that. Okay, tell me when you get this. Oh. I forgot to click the big go live button. I've done this before as well. Right, okay. Um, Let me just go into Discord and tell everyone that I'm an idiot. Give me a second. That's everyone. Yep. I am big idiot. It is starting now. Okay, so yes, but I've been in voice chat before, Matt, and we all remember how that went. So okay, so you can see it. Right, let's start again. For fuck's sake. Right. Let's try that. It's like, okay. So, privilege escalation. So I've had to throw this one together pretty quickly, because I'm quite busy this week. So I apologise if it's a bit rough around the edges. But yes, we'll see how this goes. So, I shall be covering Linux privilege escalation. This isn't Windows privilege escalation. Often they're used for very different things. Linux is used for sort of hacking servers, as opposed to Windows is usually used for taking over, personal computers and things like that. On bug bounty programs, you're a lot more likely to come across Linux Privesc. But on sort of pen tests, I suppose Windows Privesc more. I don't know anything about Windows Privesc, so I'm just sticking to Linux. Right. Okay. Why? Why would we ever want to elevate our privileges? Once you've got into a machine, why do we need more than that? Well, usually when you get into a machine, you have a lot fewer permissions than you would like. Web servers like Apache and Nginx drop permissions to a sort of low power user by default. So even if you take over a PHP script and get a shell, you can't do anything except for very bog standard things like, checking what machine you're running on, getting an IP address, things like that. Often, if in a properly configured system, the PHP user won't even have access to the web root. So the classic thing of uploading when you've got an arbitrary file upload vulnerability on a website where you upload a PHP script, often that... Sorry, I'm being spammed in Discord, I'm just going to mute that. Often that won't work on a proper web server because the PHP user won't have the ability to write to that directory and therefore won't have the ability to actually execute the shell. Right, let's see. We actually want control over the box so that we can pivot to other machines on the network or take over the system, so actually write to that web root or start filtering things as it comes through. And also just simply access to other local systems, so things like databases, credentials, stuff like that. Often you can't get as an unprivileged user. And stepping back a bit, why do we actually want control over a machine? Because if you're doing a bug bounty, just saying I have a shell on the machine isn't going to get you that much. And if you're doing a proper pen test, the high level management isn't going to really see isn't going to really understand what it means to have a shell on a machine. Having the ability as root to take over the website is a lot more effective at convincing them that this is something that needs their attention. So yes, obviously as an attacker, as a malicious attacker, they want root because they can do more damage, but we aren't attackers. I'm going to go to the disclaimer here. This is a really, really important thing. Do not do this without full permission from the owner. And I know I say this like every single time, but without back in ye olde days, this was the original hack. When things were running on big mainframes, internet wasn't a thing. Sort of memory corruption wasn't really fully understood. The actual hacks people did was trying to get more permissions on a machine. And as such, the legislation for this is actually like written for this. The Computer Misuse Act was actually mostly targeted at this sort of stuff. So just don't. Just only do this. Like, even if you're on a pen test, you're doing a bug bounty, or even a pen test, you might want to check with the client first to make sure that you can do this, because this gives you complete access to databases, everything coming through, and they'll get quite unhappy if you get root and didn't ask them. Anyway, let's move on. So let's cover the very basics. You've got simple misconfiguration, so things where you actually haven't dropped privileges. So you'll see lots of people when they're writing, Flask web servers and such like, not actually drop permissions. So they'll run a web server as root, and then you can just get in through that way. Once you've hacked it and got control over the box. Even if they haven't, often they'll leave sudo access open to that user from when they were setting it up. Or the user will have SSH access to another machine, or even as root to the same machine. I've seen that. And even if they haven't misconfigured it particularly badly, often especially in small programs, the web user will actually have database access so that they can interact with logins and things like that. And as such, just by getting that, you can exfiltrate a bunch of credentials without actually having to do any work. So check what you have first before starting to do some of the more exotic stuff. So, onto the more exotic stuff. We've got things where people actually try. So you've got things where, for instance, sudo is allowed for a user, but only for a minimal set of programs. Set UID for some binaries that aren't necessarily particularly well written, and sort of general insecure default configuration or workarounds that admins have applied. So let's start with sudo. So most of you probably come across sudo if you've used Linux before, but if you haven't, I'll quickly describe it. It's like on Windows when you right click and click run as administrator. The idea is running predefined programs, running a small set of programs as admin, or as root as we call it on Linux, is more secure than just running everything as root in case you might need it. Sudo is very well written in that it drops the LD preload and path environment variables. Just to quickly describe what those are. LD preload allows you to inject arbitrary code into a program, similar to DLL injection on Windows. And the path environment variable allows you to specify where it looks for programs. So if when you type into the console bash, for instance, it has a list of paths it checks through to try and find bash. If you add to the beginning of that a directory you control, that means if someone launched bash, they'll launch your program rather than the one they're expecting, and that can lead to some quite spectacular exploits. However, most programs aren't actually designed to be run securely as root. So I think I have an example here of... Oh, that's not supposed to happen. Okay, give me a sec. I shall drag this down. There we go. So, this is actually quite a classic question you'll see on the various security stack exchanges, as how can I do this very dangerous thing as root? So this person here wants just general users to run apt-get, and this is a question you see thousands and thousands of times across the internet. How can I get standard users to be able to update the system without root? And the answer is you don't. I mean, you can in safe ways, but there's so many pitfalls, it's probably best just not to. So I have the top voted answer, but the answer to this is this person's trying to actually run the binary directly as root. And I think if I bring this up, I actually have this on a shell. If I can, yes, here we go. So I've actually set up this thing here. So if you notice here, if I run ID, I'm not root, I'm a normal user. And for instance, if I tried to read a file that's protected, it wouldn't work. But I've given myself the permission to run apt-get as root. So the way you can check what permissions you have under sudo is doing sudo -l. And whenever you get onto a Linux box, this basically should be the first command you run. So I type in my password and it tells me, okay, so this is how it's configured. So this is the place it looks for binaries on. You can't control that because it's well written. It env resets, it clears the environment, mail bypass. If you ever type in the wrong password, it will send an email. That's when the sort of "this incident has been reported" message comes up on screen. But it will say you can run this as root. And because I haven't specified arguments, it means I can run this with any arguments. So I can run sudo apt-get, and that one's fine. So I could do sudo apt-get update, and that would update the list of packages. I could upgrade the packages on the machine. But instead of that, if I just copy and paste this bit, sudo. This will allow you to run apt-get. So this runs apt-get, but before it runs /bin/sh, which is a shell. So actually, let me change that to bash, because bash is better than sh. So look, I've got root. If I type in ID, I've got root. I can cat secret files, like that. Now, obviously memorizing all of these tricks, I'll say now finished updating. Memorizing all these tricks is basically impossible. Like I think I could maybe vaguely remember like 2 or 3, but your best bet for this sort of stuff is a amazing website called GTFO bins. It gives you a list of, if you can run any program as root, you should check through the GTFO bins list first. If I bring up GTFO bins, it gives you sort of, like for instance, if I go to the apt-get page, in fact, this is where I learned about this specific vulnerability, is it will show you how to actually exploit it and get a shell. And you can sort things out through, like, for instance, if I go to shell, it will show you what can you get a root shell with, file read, so if you don't actually care about running a shell, but you want to read a password file or a flag, these programs will do it for you, and it will give, you know, for instance, if I go to ed, it will show you how to edit the, how to do all these things. It's a really good website. I strongly recommend checking it for the CTF. Right, anyway, moving on. So, setuid. Setuid is a lot more low level than sudo. In fact, setuid is actually part of the Linux kernel itself. It's a permission you set, just like read and write and execute. And all it does is allows the program to run setuid, which is a C function you can call that allows you to change what user you're running as. So it allows you to impersonate someone else. Now, this is used a lot by, for instance, old versions of ping had to craft the packet manually. Yeah, I'll send the link to the website afterwards. Don't worry, Matt. So, what was I saying? Oh yeah, so ping actually had to manually construct the ping packet because, you know, it's not a TCP packet, it's not a UDP packet. It had to build it up itself. But you want every user to be able to run ping. You just don't want it to be root only. And they're very security reasons why you don't want anyone to be able to construct their own packets. Generally because you can use it to attack other people. So what it did, the old version of ping, is it would set itself to be a setuid program. It would use a setuid system call to become root, and then do all this stuff, and then close. Now, setuid can only be set by the user it's trying to impersonate. So only a root can create a program that's setuid for root. The problem with this is that because it's very low level, it doesn't have pretty much any security measures at all. The only one it has is dropping LD preload. LD preload, as we said before, allows you to inject arbitrary code. But that's it. That's all it does. In fact, that's not even the Linux kernel. That's done, I think, by ld.so, which is the dynamic linker. But it doesn't clear path. So, as I said before, you can create a custom path by setting the path environment variable, put your own version of the program in it, and it will execute that instead of the thing it's supposed to, if it uses a shell anywhere in it. So the system function, like os.system on Python or system on C, you can inject your own shell into that and get root that way quite quickly. Apart from that, the exploit's quite similar to sudo, so all the GTFO bin stuff works. Anything that's not configured to be root that allows you to start executing code or doing bad things can be exploited in pretty much exactly the same way. Set UID. Race conditions. Okay, so let me bring up. I think I have this here. Yes. So, programs are often written sort of in isolation, not expecting the state in it to change. So if I bring up my shell here, this is a simple Python script. What it does is it repeatedly opens a file /temp/script.sh and writes to it the command echo all is fine. It then closes that file and runs it. So this is quite a contrived example, but you can imagine, for instance, a program using a temporary file. A temporary file is quite a common attack vector, or sending commands down a socket or something like that. It then sleeps so that my screen isn't spammed and so you can see what's going on. So how do I hack this? Well, if I could somehow, in between these two lines of code, inject something, so rewrite the file before it has a chance to run it, I could easily get it to run anything I like. So I can demonstrate that with my attack script here, which doesn't have any sleep. It just repeatedly tries to open this file, writes a command into it, and then closes it, and does this on loop. So if I run the victim script, you'll see it's running the command saying all is fine over and over again. But if I run my attack script on top of it, so speed.py, there you go, it's overwriting the file before it has a chance to actually run it and get it to write something else. I'm getting it to just say something else, but for instance, I could get it to, I don't know, I could get it to list some, the contents of a directory. If that works, please. There you go. Look, it's listing the contents of the directory. And you can imagine that this sort of exploit can be quite powerful. And it's very difficult to see it in isolation. If you're writing your own program, you don't think about how necessarily it could interact with other programs that you haven't written. And often this pops up in quite surprising places. So actually one of the things that started getting me into hacking properly was the dirty cow vulnerability, which was actually a kernel level exploit. The Linux kernel, when you asked for more memory in a certain way, was vulnerable to a, what's it called? A race condition, where if you ran another function before it had a chance to properly allocate you that memory, you could actually start getting, you could start exploiting it. Like, I can't remember the exact details. Live Overflow has a really good video on this. I'll link that in the description. But yeah, it's something you definitely want to watch out for in your own code, because it's very easy to miss. So let's have a look. So misconfigured services. This is quite a general term I'm using here. It's a context dependent. If the way you hack an Apache web server is very different from an SSH server, or a Kerberos server or something like that, you'll get a sort of feel for this with experience, both generally about what misconfigurations exist, and specifically with individual systems as you get experience with those specific systems. But if you want a CTF or a pen test and you don't actually know how to hack it, you can often Google common Apache misconfigurations or something like that and just go through them. There are scripts that will do this. linenum, which I'll again probably put in the description, that allows you to... So I'm just getting spammed in the chat. Right, linenum sort of does a lot of this by default for you. Metasploit has a bunch of modules for it. But yes, this is something you'll pick up just as you deploy and write these systems. So for instance, people allowing SSH access with a password, things like that. People allowing insecure Apache modules. So And finally, the easiest Privesc of all is people being stupid. So often people just leave their passwords lying around. They'll accidentally type it in as a command and it'll be in their bash history. Or they'll have a plain text file of credentials because it makes CI easier. I've seen this on many systems, and of course I've done it myself. It's very easy to do. It's very easy to rationalize it. It's a good idea. But it means that privilege escalation becomes trivial. You just find the password and then type it in and look, you've got root. Often you'll have, especially on sort of user systems, there will be automated tools where the admins have just got bored of repeatedly doing the same task, so they've hard-coded in some credentials to a program and left it running. I have come across this, and again, it's just a matter of getting the creds or getting the program, extracting the creds from the program, and then just typing them in. You've got root. It's very easy. And it's very easy to get sort of caught up in, oh, well, I think there's a race condition in this database. Like, if I write to it and read to it at the same time, I'll be able to get... If you can just find a CSV with all the passwords on it, don't bother trying to do something complex. Prioritize the easy stuff first. Anyway, that's it, mostly. I have put on the CTF site a bunch of challenges. That's one of the reasons why this talk was late. So you can have a go with that. I'll be in the Discord. Very happy to help anyone who has any issues trying to get this to work. But yeah, I think that's it. See you in the Discord. Oh, and make sure to vote in the elections for who you want to be in the committee. I think you can still do that. I'm not sure. But make sure you do that if you haven't. Anyway, that's it. So, see you in the battlefield, gamers. I'm going to be in Discord.